Welcome back to another video. This is Dr. Tarcia Hubert here, and in this video we are going to be talking about equivalent logic statements. Okay, so we're going to be looking at and using truth tables to determine if two logic statements are equivalent. Alrighty, so we're just going to jump right into some examples. There's no terminology that needs to be discussed here. We're just going to look at some examples, and starting off with this very first example, example 1. We want to show that P or not Q and not P implies not Q, the if then, are equivalent. Okay, so notice we have two simple statements, P and Q, and then there's a not Q involved and there's a not P involved. So I'm just going to start with our basic truth table. So start with P and Q because I only have two simple statements. And remember, we start off true, true, false, false. And then alternate your true and falses. And now, since I have a not P and a not Q involved, I'm going to go ahead and do a not P and a not Q column. So not P will be false, false, true, true. And not Q will be false, true, false, true. All right, so now I'm trying to show that P or not Q, and if not P, then not Q are equivalent. So now I need to construct the truth value for those. So P or not Q, that means I'm looking at the P column and I'm also looking at the not Q column. Now remember, the or statement is true when at least one of the statements are true. So here the P is true. Here they are both true, so it will be true. Here neither one is true, and here the not Q is true, so it will be true. So this will be the truth values for the P or not Q column: true, true, false, true. All right, now let's look at the if not P then not Q column. So I'm looking at these two columns. Now remember, with the conditional, the if then statement, it is false when the first statement is true and the second statement is false. So remember, I actually like to go and find that case first. So where is the first statement true and the second one false? Here. So that third one would be false, and then it doesn't mean it can only happen once. So I definitely want to check all the other cases to see if it happens again. So this one, the first one is true, but the second one is false, so it does not happen here. So that means the rest of these values would be true. Okay, so now how do I determine if these statements are equivalent? Well, I look at the truth values of them and I see if they are the same. If they are the same, then those statements are equivalent. If they are not the same, then those statements are not equivalent. So if I look at these two, true, true, false, true, 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 false, true, they are the same. So since those have the same exact truth values, then that means those two statements are equivalent. Now there's a second part to this problem. I just erased the truth table so that I have room to write the second part. But the second part is we want to write an equivalent statement to the bill receives majority approval or the bill does not become law. Okay, so our first simple statement is the bill receives majority approval. So our P would be the bill receives majority approval. And then the second statement is the bill becomes law. So our Q would be the bill becomes law. Now, the statement that we want to write something equivalent to is the bill receives majority approval or the bill does not become law. So we want to write an equivalent statement to P or not Q. And since it's the second part of part A, which is we found out that P or not Q is equivalent to not P implies not Q, then our equivalent statement would be if the bill does not receive majority approval, then the bill will not become law. So that's our not P. If not P, then not Q. So if the bill does not receive majority approval, then the bill will not become law. And so that's how you would create an equivalent statement using the fact that we know that P or not Q now is equivalent to not P, then not Q. If not P, then not Q. All right, let's look at another example. In this next example, we want to look at statements that actually involve three simple statements. So in this example 2, we want to determine if P or R implies not Q. So if P or R, then not Q, and not P and not R implies Q. We want to determine if those two statements are equivalent or not. And notice we have P, Q, and R. So this time we're going to have a truth table that's going to be bigger. So I'm going to try my best to make it all fit on here, but I think I'm going to need this whole space. Yes, and you can see it all. So I'm going to start off with P, Q, and R. And remember, whenever you have three simple statements, you'll actually have 8 rows in your truth table. So your first column starts off true, 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 false, 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 false. And then your second column alternates every 2 times. So true, true, false, false, true, true, false, false. And then your third column alternates every 1. So true, false, true, false, true, false, true, false. All right. Now notice we have a not Q, a not P, and a not R. So since we have a negation of all of those statements, I'm going to go ahead and negate each one. So I'm going to negate not P, I'm going to negate P, I'm going to negate Q, and I'm also going to negate R. Alrighty. So the negation of P would be false, false, false. And I'm trying my best to keep these lined up. True, 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 and true. Alright. Then the negation of Q would be false, false, true, true, false, false, true, true. Then the negation of R would be false, true, alternating. Okay, so I have the negation of each one. Now I'm just going to start with this very first one. And before I can do the if then, I need to know the P or R. So P or R. Remember, the or statement is true when at least one of them is true. So I'm looking at the P column and I'm also looking at the R column, all right? So here, they're both true, so that would be true. Here, one of them is true. Here, both are true. Here, one of them is true. So I'm gonna have true for the next 3 statements. Then if I look here, they are both, one of them is true. So it'll be true again. Here, they are both false, so that will be false. Here, one of them is true, so that will be true again. And then here, they are both false, so that would be false. So this is what my P or R column would look like. So now I want to do the P or R implies not Q. So this time I'm going to be looking at the P or R column first, and then the not Q column second, okay? Now with the if then, remember that the if then is false when the first statement is true and the second statement is false. So I'm looking for that case, which is this first one. This is what I'm looking at first, P or R. So the first one is true, the second one is false, so that will be false. Here again, the first one is true, the second one is false, so that would also be false. It doesn't happen here, so that will be true. It doesn't happen here, so that will be true. It happens again here. The first case is true, second one is false, so that would be false. It doesn't happen here. It doesn't happen here, so it will be true. And it also doesn't happen there, so that will be true. So our P or R implies not Q will be false, false, true, true, false, true, true, true. Okay? So I know what this truth value is. Now I need to know what this truth value is. So before I can actually get there, I need to do the not P and not R first. So not P, and not R. I need to do that column first. So I'm looking at the not P and the not R. And remember, an and statement is true when they are both true. So not P and not R, they are not both true there. So that would be false. That would also be false. That would be false. That would be false. That will be false. So the first 1, 2, 3, 4, 5 will be false. So 1, 2, 3, 4, 5. And then the sixth one would be true. The next one would be false. And the last one would be true. So I will have a true, false, and a true. Okay, that's because the and is true when they are both true. All right. So now I can do the last part, which is the not P and not R implies not Q. I actually made it all fit. I was curious to know if I was going to make this whole table fit on my board, but I made it work. Okay. So we're looking at this column first, and we're looking at the Q column second. Okay. So remember that the if then is false when the first statement is true and the second one is false. So I'm looking for that case. So the first statement is only true in these two cases. So in the Q column, I'm looking to see is the second one false in either one of those, and it is in this bottom one. So that last statement would be false. That means all of my other statements would be true. One, two, three, four, five, six, seven, eight. Yeah. So the only one that's false is that very last statement. So now I was trying to see if this statement was equivalent to that statement. So I'm looking to see, do these have the same truth value? And I can already look at it and tell they don't, because the first one here is false. The first one here is true. So since they do not have the same truth values, then these statements would not be equivalent. Okay. So that was a lot of work to determine if they were equivalent or not. But once you go through all of the work and you look at it and you see, okay, those are definitely not equivalent. So those are not equivalent statements. For this last example, we want to figure out which of the following statements is not equivalent to Miguel is blushing or sunburned. Okay, so we first need to identify our simple statement. So it sounds like we have two simple statements. The first one is P, Miguel is blushing. And the second one is Q, Miguel is sunburned. Sunburned. And so we're trying to figure out which of these statements is not equivalent to Miguel is blushing or sunburned. So P or Q. All right, so now we just have to take the statements and translate them into symbols. So the first statement is, if Miguel is blushing, then he is not sunburned. So it sounds like Miguel's cheeks must be red, and we're trying to figure out, is he blushing or is he sunburned? Okay, so if Miguel is blushing, then he is not sunburned. So if I translate that into symbols, then my first statement would be, I'm gonna just write it over here. My first statement would be if P, then not Q, because if Miguel is blushing, then he is not sunburned. It's the same in symbols as P implies not Q. The second statement is Miguel is sunburned or blushing. So basically it's saying what we said at first, but it just switched the order. So that would be Q or P. So the third statement is, if Miguel is not blushing, then Miguel is sunburned. And so that would be in symbols, if not P, then Q. The last statement would be, if Miguel is not sunburned, then Miguel is blushing. So that would be, if not Q, then P. Okay. So this will be all of our statements and symbols. P, if P, then not Q, Q or P. If not P, then Q. If not Q, then P. Alrighty. So what we want to do is we want to go through and determine which of those statements are equivalent to our original statement P or Q. So that means we need to do a truth table for each of these. So the good thing is we only have two simple statements, so our table won't be as big as the last one, as far as the number of rows, right? So we have true, true, false, false, true, false, true, false. And all of these statements have a not P and a not Q, or there's a not P or not Q in at least one of those statements. So I'm going to go ahead and do a not P and a not Q column. So not P would be false, false, true, true. and not Q will be false, true, false, true. So now I need to know what does the truth table for P or Q look like? And we already know that. We just want to go ahead and put it in the table so we can compare side by side. But P or Q is true when at least one of them is true. And that's in all cases except the last one. So that both true here, P is true here, Q is true here, and none are true in the last case. So that would be true, 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 false. All right. So the first statement we want to do is P implies not Q. So that means I'm looking at the P column first and the not Q column second. Remember, the if then is false when the first statement is true and the second one is false. So it will be false in this first case. It would be false in this second case. No, not the second case. Sorry, I was looking at the wrong two. So it would not be false in the second case because it's P and not Q. So it will be true there, and it will be true in all the other ones as well, because remember, in order for it to be false, the first statement has to be true, and the first statement is true only in these two, and then it's only false in the second statement here. So you can already look at this and tell that's going to be your answer A. You could actually stop right there, but I want to go ahead and just complete the problem so you can see that the other statements are equivalent to the P or Q statement. So Q or P, you basically looking at the Q and P column, and that's true as long as one of them are true. And so one of them is true here, one true here, one true here, and none in the last one. So that would be true, 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 false. Same exact truth values as the original P or Q. So those two are equivalent, all right? Then if we do not P implies Q, we're looking at the not P column first, the Q column second. Remember, with the conditional, it is false when the first one is true and the second one is false. So not here, but in this case here, the first one is true, the second one is false. So the last one would be false and all the other ones would be true, which is the exact same truth value as our original statement. So that statement is also equivalent to P or Q. And then the last one is not Q implies P. So we look at the not Q column first and then the P column second. We're looking for the case where the first one is true and the second one is false. Not that case, but that case here. So the first one is true, second one is false. That means that one is false and all of the other ones are true, which are the same truth values as the original P or Q column. So I just went ahead and did the rest of these so that you can see that all three of these statements are equivalent to P or Q, and the only one that wasn't equivalent to P or Q was the if P then not Q. So that statement would not be equivalent to P or Q. All right, and so that's all I want to show you for how to determine if two statements are equivalent by using truth tables. You just lay out the truth tables, go through them, and see if you get the same exact truth values. If you have any questions or comments, make sure you put them in the comments below. If not, I will see you in the next video.